Dynamics is the topic, and we are discussing this question. The two balls stick together. As you said that it's a case of coalescence, I have found the final velocity, and I can use it to find the final kinetic energy. Final kinetic energy Now I'm working for, I have found the final kinetic energy. They have stuck together, so they are moving together. Initially, one particle was moving, other particle was stationary. So I'm taking its velocity only. This is the initial. Now, examiner is asking for a fraction. What fraction of the kinetic energy is lost? Can you make this subtraction for me? What is 1 upon 2 minus 1 upon 6?
It is 1/3.
Now I'm working for the fraction. So fraction is 1/3. And the initial was half. So after this long working, this is the answer. Electric field is not in our course, so I can leave this question. A stationary toy gun fires a bullet. Which statement about the bullet and the gun immediately after firing is not correct? These questions are always very tricky. Options are very close. The language is twisting. The force exerted on the bullet by the gun has the same magnitude as the force exerted. This is exerted by the gun on the gun by the bullet. He's trying to engage Newton's third law. He says not correct, but this is correct. It is Newton third law. The force exerted on the bullet by the gun is in the opposite direction to the force exerted. This is also a right. The gun and the bullet have the same magnitude of momentum. I use this idea. Bullet has small mass, large velocity. And if it's an isolated system, momentum would be conserved. The kinetic energy of the gun, that is wrong because kinetic energy is not conserved. So I hope you can get this point that kinetic energy is not conserved. So this is a good theory question. The resultant force on a raindrop of mass m falling vertically with velocity v is given by this equation, where k is a constant and g is the acceleration. Equation is very clear, looking for weight minus kv square. And he says he's using the word resultant force. I'm taking the upward force as kv square. The raindrop eventually reaches terminal velocity. When terminal velocity is reached, resultant force will become zero. So when you reach terminal velocity, let's model that. Now this is the equation. He is putting velocity on one axis and mass on the other. G and K are constant. So I'm rearranging the equation. V square is equal to m So I have shown the working, and there is a square or under root function here. So you can see here that there is a square function which is being related. Now you can see which graph suits us. It can't be a straight line, and a straight line is not an option actually. Square functions, there is an under root function actually, and it's a good memory to call back. If there is a square on x, the graph will be bending towards y-axis. And if there is a square on y, the graph will be bending towards x-axis. It's a reverse. So it would be better if I recall for the math support. This is a graph if it's y and x. This is the graph of under root x or square x.
So the y has the under root. No, x has the under root, so it should bend towards the y.
No. I repeat, when there is a square on y, it bends towards x. And when there is a square on x, it bends towards y. It's opposite.
So x has the square right now. So v square.
I write the equation actually for clarity. It is y square is equal to x. Y is. So this is a memory. It's better to learn this, especially if just like if someone is not taking maths. This is a graph of y square is equal to x.
Okay. So v square is supposed to be the terminal velocity in this one.
He has made us clear that v is the terminal velocity.
So it will bend towards the m.
I make the other one also, and you can note them down because they're very helpful to maths equations. Two famous math sketches. Now, these are two important graphs. You should learn them. They are good memory. Now, you have to see which one suit us.
So it should be bending towards m. So either B or C.
There are two options, B and C. Now,
B
B is starting from 0. This graph cannot start from 0, or it can start from 0. This is a question. You should use a basic math. There is no intercept in this equation. There is no plus C. If you see the main equation, if you see this equation, there is no intercept. If you put M0, you will get V0. And logically think, C is possible. C means what? C means when mass is 0, velocity is not 0, because it's showing an intercept. So logically think, is it possible? No mass and some velocity.
It's not possible.
It's not possible. So that is why B is the right answer. A mass m1 traveling with a speed u1 collide with a mass m2 traveling with u2 in the same direction. After the collision, mass m1 has a speed v1 and mass m2 has a speed v2 in the same direction. The collision is perfectly elastic. Perfectly elastic means relative speed of approach is equal to relative speed of separation. But how we find the relative speed of approach? This is the formula. And remember the rule, when arrows are in the same direction, you have to subtract them. When arrows are in the same direction, you have to subtract them. So what is the relative speed of separation? I can write U1 minus U2. And what is the relative speed of?
So arrows, when that in the same direction, they will be subtracted.
But it's not getting fit. The equation is not getting fit. We can use the second approach. This is the second option. What's the formula for impulse?
mv plus u, v minus u.
This is a possible formula. So I have engaged all of them, and he says which equation is not correct. What's the formula? Main formula for M1 U1 plus M2 U2. Now, one by one, look all the options. I have shown all the formulas, and you can try first the option A. Do you think the first formula can justify option A?
No, there's a square. There's no square like anywhere in the formula.
Very good. So what formula is there which actually engages square, which is for elastic collision?
The kinetic energy.
Yes, very good. One, 3, and 4. Now I've written actually all the formulas required in this discussion. Now you said that 1 is not fitting anywhere. That's fine. Do you think 2 can justify option A?
Uh, 2 can justify, yes.
Good.
If we switch the positions of v and u, it can.
Very good. So 2 is justifying A. What about 3?
Yes, 3 will justify the first equation. If we take m1 common in them,
Hmm.
like m1 minus m1 v1, m1 u1 minus m1 v1, then it can.
It means this is justified as B. What about option C?
Option C, I think it is being justified by the first equation.
For you can say it can come from here. It can also come from here. So it means option limit.
No, isn't D also correct if we like take it in the
No,
sense
but how
as
you justify square, whole square? Whole square cannot come from any of the formulas shown above.
okay, individually they can be squared.
Individual is there.
Okay, so the B is also being justified because V2 plus U2, those are like the final and initial.
Sorry, no, but how you get a whole square?
Uh, know about the B equation in B.
V2 plus U2.
Yes, that one.
That's coming from relative speed of approach is equal to relative speed of separation, na?
Okay.
Because arrows in the same direction is equal to arrows in the when velocities are in the same direction, arrows in the same direction are added. Arrows in the same direction are added and arrows in opposite direction are are added. Arrows in the same direction are subtracted. I have written this equation. If you rearrange, you can get this.
So when the arrows are like pointing in the same direction, they are minus.
Arrows pointing in the same direction are subtracted. This is a rule for relative speed, and arrows in opposite direction are added. So that was a good challenging question, which actually revised many things. Now, the resultant force on a raindrop, actually, this looks to be a very similar question of mass m with velocity given by this equation, where k is constant, g is, find what is the velocity of the raindrop, and it reaches a constant velocity. If I make V the subject, see this working. If you have a query, you can always ask.
I am also getting the same answer. Um, like if it comes like as easy as this, then it is also fine. Like the answer sometimes.
Because in a paper, it's a rule that all MCQs are not very difficult. And again, the same rule which people should always remember, even though MCQ paper is very tricky, but it is a very low threshold paper. And that is where you get the margin actually. A ball of mass M travels vertically downward and then hits a horizontal floor at speed u. It rebounds vertically upward with the speed v. The collision lasts for time delta t.
So we are supposed to find the impulse over time in this one.
Maybe.
And impulse is like m and v plus u.
Impulse is mass into change in velocity. This is where we call it impulse. So this is the ball is dropping and rebounding with speed v. The collision lasts for delta t. What is the average resultant force? What is the formula for force in this chapter? Force is equal to impulse upon time. This is the formula for force. Impulse is equal to m v minus u upon delta t. The ball is rebounding. If the ball is rebounding, where do you think the force will be acting? It will be acting upward by the ground, or
Like the ground will exert the force on the ball.
but the force will apply upward or downward? The
Upwards.
force, otherwise the ball won't go up. That's a logical thing, no? If the force should be upward, so there are two options. Now, velocity is changing its sign. So if the downward is positive, upward is minus. Now see this working.
Why did it change from like v minus u to v plus u?
Because the sign is changing reverse direction. Because when direction reverses, velocity as a vector will change its sign. So what answer should I select?
D.
An astronaut has a weight of 660 Newton when she is standing on the Earth's surface. The acceleration of free fall on the surface of Mars is 3.7. What would be the weight of the astronaut if she stood on the surface of Mars?
First, we
So,
divide 660 with 9.8 and then multiply the answer with
the
3.
ratio method, na? So we can take it like this. Mass doesn't change.
It is coming as 249.8.
Sorry, 40.
249.8. So almost 250 Newton. C.
A car accelerates from rest in a straight line with constant acceleration. Which graph best represents the variation of the momentum of the car with the distance s traveled by the car? P and S, momentum and S.
So constant acceleration will mean like increasing velocity.
Acceleration means velocity is increasing. So what's if we make a logic here? This
And it will increase like at a constant rate, the velocity.
ah So I've shown the impulse when momentum is changing, it means it is impulse. The tricky part is that he's relating momentum of the car with the distance traveled by the car. That's a tricky part. How we can relate momentum with distance.
So momentum is directly proportional to the velocity. So and
Momentum
velocity
is
is
directly proportional to velocity. Huh, that's right. But we should try to get a relation, a formula that somehow momentum and distance. Momentum can be related with kinetic energy, and kinetic energy can be related to work done. Work done can be related to distance. Because that's sure that momentum is that's right. Momentum should be increasing with distance, but the main thing is the relation. We should find a relation. That's right. D cannot be the answer because momentum, if velocity is increasing, momentum is also increasing. But that only get us to cancel D. Now we need, can you make a think of an equation which can relate momentum and distance? like something 2as is equal to v square minus u square, if we can think on that. Or impulse is equal to resultant force is equal to impulse upon time.
Can we use like the S is equal to ut plus half at square?
But how we can relate?
But the impulse won't be in there.
Huh. The main challenge is this. This is the main challenge, that how we can, this is right, it is either A or B or C. D is wrong because it shows momentum is constant. So that is not selected.
Like, can't we do the velocity is equal to displacement over time?
You can try that.
Because if it is like the momentum is increasing, then the velocity take the
Hmm.
impulse over time, that will give us the force.
This one.
Yes, I think.
But that is not possible because it is not the resultant force. It is, I hope you remember now. It's a mathematical issue now. It's V square. If you see this working,
So it should bend towards the y-axis, the S, towards the S.
hmm,
So only option A is bending towards S.
yes. So this means that this is a very helpful, sketches are a very helpful source of solving such questions. And momentum, because you see now that momentum is actually proportional to under root S. This is a mathematical relation. So we selected this one. Well, this is all for today. And